All right, today you're going to solve rational inequalities. And today's lesson can get really tricky. So you're going to want to pay attention and take good notes. All right, first of all, a rational inequality is fancy for fractional. And then inequality means it's going to be a less than, a greater than, less than or equal to, or a greater than or equal to. And the solving part is we want to find all the answers. So we want to find all the answers for fractional inequalities. Before we do that, you're going to have to learn a new word. And here is the word right here, asymptote. It's a line that a graph gets really, really close to, and we call that approaching, but it never really touches the line. And you played this game all the time with your sister or brother to annoy them. It's when you took your finger and put it really, really close to them and said, "I'm not touching you, I'm not touching you, I'm not touching you." And then you just wanted to tick off your little brother or sister so that they would start screaming and they would go and run to mom. And then you could always say, "But mom, I never touched them." So you played the asymptote game when you were little. So let's give you a mathematical version of the asymptote. I'm going to take this graph, y equals x minus 4 over x plus 3. Now, I took out a graphing calculator, and since it's a binomial, I put it in parentheses. I graphed it, and here is what your picture looks like. That red line right there is this in picture form. And since this is a fraction, we know the denominator can't ever be 0. Okay, so we know that. So when I look up here, my denominator is x plus 3, and that can't ever equal 0. Well, if I solve that, that means the x value can never be negative 3. Now, I want you to look over here at this graph. And I'm going to take this line right here, and I'm going to make that just a little thicker, thinner. And I'm going to go to where the x value is negative 3. 1, 2, right here. This is where the x value is negative 3. And this is the line x equals. Do you see the asymptote happening there? See this red line? It gets really close to this straight line. And then this side of the equation gets really close down here. But it's never, ever, ever going to touch. I don't care what you say, Tyler Gilbride, it will never touch. Tyler, to this day, refuses to believe this. He keeps saying, nope, no, it's eventually going to touch. No, Tyler, it's not. Never, ever, ever. Kind of like Taylor Swift's song. Want me to sing Taylor Swift? Yeah, no, I didn't think you did. That asymptote is going to play a big, let me say it one more time, big part of today's lesson. So here we are. We're getting ready to solve this problem right here. First thing I always do is I check for an asymptote. I look at the denominator. Got a denominator of 4. I got a denominator of 2. There are no variables in here, so I don't have any asymptotes. Woohoo! I can solve this problem just like yesterday. I'm going to multiply this by 4, this by 4, this by 4. Cancels out, gives me A. Cancels out, gives me 2. 8. Negative a is less than 8. Divide through by a negative, and I get a is greater than negative 8. Awesome. So I can leave this as my answer. Or I can elect to, let's find a number line. Okay. I can pull out a number line. And I can elect to graph my answer. Okay, here's negative 8, and I want to be greater than negative 8. So that means I would graph that way on the number line. Let's make that bigger so you can see it. Let's come over here. Let's make that line bigger. And yes, there's my dog. And that should be an open circle. So let's change that. There. All right. I'm going to erase all this. And now I'm going to give you a visual as if you did it on your graphing calculator. What I did was I took this problem and I divided it into 2 equations. A red equation, which you can see right here, which is the left side, and then I took the right side and I made it into an equation. So y equals 2 is this line right here. And then the red line, this side of the equation, y equals a over 4 minus a over 2, ended up looking like this line. And now the question was asking me, where is the red graph less than the blue graph? Okay, where is the red graph? Oh, the red graph over here. This is where the red graph. Let's change that color. All right. That's where the red graph is less than the blue graph. And if I look really closely, that number right there is negative 8. Hey, that's what I got down here, right? There's my negative 8. Let's readjust this so it's all good. And all these numbers above negative 8 make the red graph flow below the blue graph. Kind of cool. So you got a lot of different options on solving this. Okay? Let's do one more problem. All right, so when you're solving inequalities, you always check for the asymptote all right, because this is a fraction. So where's this fraction in problems? Oh, where does n plus 4 get me a 0? All right, because n plus 4 can't equal 0. So n can't be a negative 4. All right, here I got a problem right there at negative 4. That's my asymptote. All right, so now that I know where I got a problem, let's just solve this equation. All right, so just like yesterday, multiply this by n plus 4, multiply this by n plus 4, cancel, cancel, n minus 2 is greater than 3n plus 12. All right, solve away. Negative 2 is greater than 2n plus 12. Move that negative 12 over to make it negative 14. 2n, divide by 2, divide by 2. n -7. Let's flip it around. N is less than -7. Oh, wait a second. -7. That's that number right there. So here's where it gets tricky. You think that your answer would be anything less than -7, but not fast. No, not right. Let's take a look at this graph. All right, so things are getting a little hairy scary here because it's not just easy, just do the steps math like it was in freshman year or sophomore year. So I'm going to take a check on my graphing calculator. I'm going to take this and I'm going to look at this red graph. And then I'm going to take the other side, I'm going to make it a blue graph, and I'm going to graph them on a graphing calculator. Take all this stuff right here and group it together because I don't want to lose it. And here's my graph, and that's what my picture looks like. So this is asking me, where is the red graph greater than the blue graph? Okay, here's the blue graph. It's the line y = 3, and it goes right there. Tried to trace it, you know, you get the idea. Now the red graph is right here. Is this red graph above the blue line? Nope. Is it there? No, it equals the blue line, but from here, it is above the blue line. So that number right there, the crossover point is, hey, look at that, -7. At -6, the red graph is above the blue line. At -5, the red graph is above the blue line. But at -4, I have an asymptote. Whee! There's my asymptote. And if you see, I drag that asymptote out so you can really see it. This red graph never touches this asymptote. I know it looks like it's touching right there, but it's the best I can do when I trace. So the only place that this red graph is above the blue line is in between -7 and -4. So there is my answer. From -7 to -4 are the values that would make my red graph be above my blue graph. Okay, whoops. Let's put that one back. Same thing. I look at this, and the first thing that should come to my mind is asymptotes. Because I got fractions going on here. I got 3 of them. So if I look, this 4v cannot be 0. So v can't be 0. That's okay, that's a constant. This 4 is fine. Well, that's a variable, so that v cannot be 0. So look, my asymptote can't be at 0. So if I took a number line out, and I came over here, I would know I've got a hole here at 0. All right, so I've got my asymptotes under control. Let's solve this problem. Multiply by the common denominator, which is 4v. Cross this off. 1 plus 3v is less than 28. 3v is less than 27. V is less than 9. All right, so I'll come over here and I'll circle 9. All right, so what are my answers? I know I got stuff going on between 0, 9, and less than 0, and all right. So I can take out my graphing calculator, and I can say, all right, this is going to be my red graph. And I'm going to see how that behaves versus the blue graph. All right, here's my graph. Okay, so here's my red graph. My red graph is right here. And it goes down. I know it looks like it, but didn't we say where's my asymptote? My asymptote is my V value cannot be 0. And if you look there, there's an asymptote right here. I know it's hard to see. I'll probably try and put it in a black line, but it's right there. That red graph gets really, really, really close to the line x equals 0, but it never ever touches it. And then here's my red graph over here. It's really, really close to that line. I know I'm not drawing it very well. And then it goes like that. Okay, here's my blue graph. Right there. So if I look right here, is my red graph less than my blue graph? Is my red graph less than my blue graph? No, my red graph is above my blue graph. Oops, put that back. How about over here? Is my red graph below my blue graph over here? Yep, right here it is. My red graph is definitely below my blue graph right there. Here's my blue graph. Okay, so here's my crossing point of 9. Yeah, that's what I figured out down here, 9. And here's my asymptote of 0. And between 0 and 9, my red graph is below my blue graph. So those are my answers. The numbers between 0 and 9 make the red graph go below the blue graph, and if you wanted to write that out, 0 less than V less than 9. So that's your answer. Or you could write this as your answer. Okay. Let's see how much time it is. Oh, it's an 18-minute one. All right, well, I'm going to run through the last one really quickly. Okay, my asymptotes. W minus 1 cannot equal 0, so W cannot equal 1. W cannot equal 0, and right here, W cannot equal 1. So 1 and 0, I got problems at. All right, let's solve this problem. Multiply through by the common denominator, which is a W and a W minus 1. W and a W minus 1. W and a W minus 1. Boop, boop. 3W, boop, boop. 4W minus 4, boop, boop. 5W. Okay, that's 7W minus 4 is greater than 5W. Bring that over. 2W is greater than 4. W is greater than 2. Oh my gosh. Look at all these numbers I got. Okay. So I'm going to take out my graphing calculator and I'm going to look at it again. I'm going to take this and make it the red graph. And then I'm going to take this and make it the blue graph and see how they relate to each other. And I want to know, where's the red graph greater than the blue graph? All right, well, right here, here's my blue graph. And here's my red graph. So definitely not right there is my red graph greater than my blue graph. And that is anybody less than 0. So if you look really closely right here, here's a red graph. Right there. Is that red graph above that blue graph? Right. And that's between 0 and 1. Okay, now here's the number 2. Okay, from 2 on, is that red graph above the blue graph? Yep. Oh wow, this was an ugly one. Look at this one. Wow. So my answers are any W's that are between 0 and 1 work, or any W that's greater than 2 works. Wow. That's awesome. All right, see you tomorrow.